up, everybody? Welcome to this week's episode of Hidden Forces with me, Demetri Kofinas. My guests for this episode are Vitalik Buterin and Vlad Zamfir. Vitalik needs little introduction. He is the founder and inventor of Ethereum, the first cryptocurrency-enabled, decentralized, Turing-complete machine ever created. Ethereum and Bitcoin combined make up nearly 60% of the entire market cap of all cryptocurrencies. Vlad is one of Ethereum's most prominent researchers and the leading figure in the development of Casper, a consensus mechanism that aims to enable the Ethereum platform to scale its existing architecture for use cases that reach beyond the network's current capacity, like decentralized car-sharing applications, stock markets, and online games. In this conversation, we focus our attention on the Ethereum roadmap, specifically Casper, Plasma, and the developer community's approach to sharding. I also get Vitalik and Vlad's reactions to the recent comments by SEC Director of Corporation Finance, William Hinman, as well as their thoughts about governance models in open source crypto economies. For more information about today's episode, or if you want easy access to related programming in blockchain and cryptocurrencies, visit our website at hiddenforces.io and subscribe to our free email list. You can follow us on Twitter, Facebook, and Instagram at Hidden Forces Pod for regular updates and audience feedback, including the latest information about future episodes, topics, and guests. And now, let's get right to this week's conversation. All right, guys, welcome to Hidden Forces.
Hi. Hi, Demetri.
Hey, great to be here.
It's great having you on.
Yeah, it's good to be here too.
So we were just talking about some libertarian history. You guys are fans of Doug Casey.
Yeah, well, when I was in high school, my dad would send me those conversations with Casey and those monthly newsletters pretty much every month. And I remember this had me somewhat convinced that the U.S. dollar would actually hyperinflate and the financial system would collapse. And this actually, to some extent, literally had me scared that I would basically not be able to survive unless I try really hard at making myself very useful, and this motivated me to learn a bunch of stuff.
That's really funny because Doug's a funny guy, and you, Vlad, you were looking for Doug when you found Capital Account.
Well, I mean, I kind of followed Doug on YouTube. I thought he was among the better of the libertarian sphere that I used to kind of follow on the internet. I think a lot of people in cryptocurrency still are in that sphere. I think over time I've kind of drifted a little bit away and become a little bit more maybe realistic and also absurdist.
I'm not sure the libertarian sphere, as it existed in the late 2000s, still sort of exists today. I feel like it's bifurcated in a bunch of directions. There's some that kind of moved into the cryptocurrency space, some that, in my opinion, very unfortunately turned into alt-right people. There's kind of all of these different sub-tribes. I think it's, there's obviously a lot of people who believe in the same values, but, the strategy is the way that they interpreted the financial crisis, the way that they interpreted cryptocurrency, the way that they interpreted Trump, and, all of those things. I think, movements always exist in a time and place, and they do sort of evolve as the time and place changes.
That is true. That is interesting. It is interesting, like you said, how it's fragmented into subcultures, how initially the cryptocurrency blockchain space, I mean, I guess it wasn't even conceptually thought of as blockchain, was heavily influenced by anarchism and libertarian ideals, and how that's sort of changed. Certainly, I think that's much more the case with Bitcoin than it is with Ethereum. Vlad, before we start, you got to tell our audience how you and I first met, actually virtually met, because it wasn't in person. I'll tell you from my perspective. I get on Facebook. This was months after I had been aware of your work. I'd been reading about Casper. And I get on my Facebook page, and I see a message from Vlad Zamfir. So I'm confused here how it is that I'm getting a text message from Vlad. And it turned out this was from a couple of years ago, when I had published a story, and you had messaged me, and you used to watch Capital Account. So you had learned about what I was doing from Capital Account, and you liked that show. Yeah,
it was my favorite show back in the day. I still remember being really upset when you canceled it.
That's amazing. Thinking about all the work that you've been doing with Casper and Proof of Stake, and the amount to which economic modeling goes into thinking about that, the fact that you used to watch that show was very humbling.
I was into global finance and stuff, and that's actually the kind of reason I got into Bitcoin in the first place, is because I kind of thought, oh, look, the global financial system is really fucked up, and Bitcoin is going to save the world. I kind of stopped following media after I got into blockchain.
Yeah.
But definitely,
Anyway, that was a selfish plug for a Capital account and what I'd done there because I was so proud of it, and it made me so happy to learn that, and just a really cool point of history. So, guys, I want to get right into this because there's so many things that we want to discuss. You just flew in from Singapore. How was that?
It was 2 long flights. I mean, we travel around the world all the time. We're used to it.
Anything interesting to report? Have you guys been doing any consulting work for the government in Singapore? I know that they have been looking into possibly implementing blockchain for their local currency.
I've definitely talked to various people in the Singapore government internally on token-related issues and other things, but so far it's been fairly informal.
Yeah, I would say very preliminary.
Mm-hmm.
All right, so before we get into the 2 kind of areas that I want to discuss mostly, which I think are most interesting, certainly to me they're most interesting, I think they are to the audience, and there's certainly points of confusion for me as well, and they are basically the domain of architecture, and the technology, in other words, and then the governance. But before we do that, I do want to ask you, because it is timely, that we're recording this on Sunday, June 17th, a few days ago when it was the SEC Director of Corporate Finance, William Hinman, came out with a statement around cryptocurrencies and securities. Do you feel like his statement provided any clarity for you? And if so, what was the impact?
And it definitely was perceived by the market as providing clarity that at least some cryptocurrencies are kind of safe in some sense, and we have peace in our time in the crypto industry. To the extent to which the situation is going to evolve over the next few years is, of course, still up in the air. These are non-binding statements, and they totally have the ability to reinterpret if they want to, and there's going to be a change of administration, and 2.5, 6.5, whatever years. So there are a whole bunch of unknown variables, but the way the market's interpreted it is definitely, at least I feel, as a kind of reduction in uncertainty.
I thought it was encouraging to see that they kind of understood the difference between a token and the agreements between the parties involved, and that as opposed to just imagining that if someone does a token sale, then no matter what happens in the future, that token will always be classified as a security.
Do you think that's less of a concern for the 2 of you and for the core developers than it is for the distributed app developers and people that are sort of entrepreneurs in the space trying to build and raise capital?
Possibly, yeah, because there's different categories of coins, and there's base layer protocol cryptocurrencies like Bitcoin, Ether, Zcash, and so forth. And that's one category of thing, but I feel right now the barrier to entry in terms of being able to create a new base layer that actually gets used by a lot of people is just going up and up, because people are expecting ultra fast virtual machines, they're expecting scalability, they're expecting privacy, so you can't just make a clone of Bitcoin, crank up some parameters and push it out. But there's also this other category of cryptocurrencies that's more application coins, and these application coins tend to be not always, but sometimes more centralized in nature. They're also designed around particular products and particular systems, and often enough from an economic and possibly even regulatory standpoint, they lean closer to being securities. And that is a kind of different, subcategory of cryptocurrencies that has grown a lot over the last year. And the SEC messages definitely don't give a kind of unconditional safe harbor to that category. They absolutely don't. But even still, this is an area that's people, there's substantial demand to participate in, and it's kind of evolving over time.
So you feel pretty optimistic about the direction?
Optimistic about what? Because there's optimism versus pessimism about regulatory action. There's optimism, pessimism about whether or not it'll work, and work in the sense of becoming big, work in the sense of being useful to society.
Not optimistic about the technology, optimistic about the way in which governments, specifically the United States, but more broadly global governments, are going to maybe not embrace, but sort of make room for the emergence of things like Ethereum.
On the base layer side, I think it's definitely seeing like fairly green lights on multiple fronts. And, not just in the United States, like I believe Korea is considering like unblocking like certain types of cryptocurrency trading, though I haven't been following recently too closely. But like at the same time, I do feel like government agencies like basically are going to be a bit like scared of like basically having cryptocurrency be a backdoor through which like the entire securities regulation apparatus gets unraveled, and so they would want to try to make some kind of like barrier that says like you can't use this as some backdoor way of like basically issuing company shares. So I think, like obviously, like base layer protocol cryptocurrencies are very far from company shares, but there definitely are cryptocurrencies that are much closer to that. And so there's going to be back and forth in the middle there.
You got any thoughts on that, Vlad, or should we go right into the meat and potatoes of the conversation?
I'm not a lawyer, but one of the things that I did learn that I found kind of interesting is that the definition of security has to do basically with, about this contract between like the buyer and the seller. And it's not like natively to do with the technology that underpins things. I am optimistic that everyone will continue learning about the technology.
I think it's a situation where we just need to get some clarity around it, because the language of those contracts is important, and the language of the way that the money is raised, to your point. So we can begin either with the technology. I'm inclined to go on the tech side, because we can talk about governance too, and I want to get to that towards the end. But let's start with the architecture and the roadmap. It is very challenging for me to wrap my head around the solutions and the roadmap for Ethereum because of the anarchic nature of the way in which the conversations happen. So there's you, there's Vlad, there's Joseph, there are a few people, right? And there are three main components to the solution to the problem of scale that I've heard discussed. One is POS, specifically Casper, FFG, and CBC. CBC, as I understand, is being led by you, Vlad, is that right? And FFG is something that you and who else have worked on, Vitalik?
Well, I'm like the primary kind of creator, but then there's also Danny Ryan, who helped a lot on the implementation. And I mean, Virgil Griffith helped to co-author the paper last year. And
is the FFG is the friendly finality gadget, is that a kind of compromise, transient, a temporary compromise between proof of work and proof of stake? And is that compromise driven by the politics of wanting to appease the miners, or is it about let's
So it's important to distinguish here between kind of two ideas that sometimes get called Casper FFG. One of them is like specifically the way that Casper FFG, the algorithm, works. And the reason why Casper FFG is called a finality gadget, so like the word gadget instead of algorithm, is that Casper FFG, as it's kind of described and envisioned in the paper, is sort of deliberately incomplete in some sense, right? So it handles like coming to consensus, but it does not handle what like practitioners and academics call leader election, right? So basically leader election or like proposal, like that general category of things, is basically a matter of like coming up with proposals for like, let's agree on this. And then the second step is, well, if someone proposes, let's agree on this, does the entire set of participants in the network actually come together and say, yes, we agree? So Casper FFG handles the yes, we agree, or, no, we don't, we agree part, but it explicitly leaves a kind of open hole where you can plug in any separate algorithm for proposing things. And so
for who decides who the leader is that proposes the next block? Is that what you're describing?
Basically, yeah. So like in the original kind of vision, right, the leader would start off being the existing proof of work chain.
Right.
So the proof of work chain, instead of being the kind of full consensus, would just sort of become a suggester, and the proof of stake would become kind of like a ratifier, right? So,
but you're saying the suggester is the actual longest chain, or is it actually the miner who won
the suggester? Well, the suggester is the chain acting as a kind of virtual entity consisting of all the miners, if that makes any sense at all.
Where does the leader who actually chooses the next block fall in?
Sure. So the leader is basically implicitly the miner that creates the checkpoint, so that creates the block that the gadget ends up actually coming to agreement on.
Okay, so that happens before this implementation of the consensus protocol or mechanism is put in play.
Well, the two, proof of work and FFG both kind of run in parallel, and they're both running constantly forever, but generally, yes. So step one, the proof of work chain grows to some height, at which point it proposes a new block, and step two, that block gets confirmed by the proof of stake layer.
Okay.
Yeah.
All right, so that's a good sort of general overview. Vlad, what about CBC? Now, this is, I think, am I correct in understanding that when people think about Casper in sort of the grandest visions of Casper and proof of stake and moving away from proof of work, what they're really talking about is correct by construction, Casper, CBC, what you've been working on for the last number of years?
I think firstly people think about proof of stake and this idea of using security deposits for proof of stake in this kind of blockchain-like consensus protocol. And then, like, somehow, like, the Finality gadget and, like, the CBC Casper family of protocols are, in some sense, distributed systems solutions. And, you know, they are going to be associated with security deposits and economic incentives. But Casper research really started in the economic side of the equation. And then we moved over time to, you know, after we do a bunch of thinking about, like, what is economic security? Like, how do we make sure that it's a natural equilibrium to follow the protocol? We have to actually say, like, oh, what protocol is that we want to follow? And so then we go and build these different distributed system solutions. CBC Casper is a family of distributed systems protocols, of consensus protocols.
It's a family of consensus protocols.
It's a family of consensus protocols.
You and I spoke about this recently, the one time that you and I had a chance to talk, and I got a sense from what you described that there are multiple different solutions. You apply different types of consensus to different types of problems. Mm-hmm. Let's see if you can try to explain that to me, because I didn't understand it when you spoke to me before. I want to try to see if I can understand it now and provide clarity to my audience where it's possible. Maybe you can just give us sort of the grand vision for what Casper is and how you want to apply proof of stake and consensus in order to move this, scale the network.
Sure. Well, firstly, let me say that, like, proof of stake by itself is just a solution for Sybil resistance and governing the nodes of the network so that they don't attack the system, or
right.
If they do, that it's expensive. It's not by itself a scalability solution, although it helps in, for example, sampling nodes. It's easier to sample nodes in proof of stake than proof of work. And then, you know, we kind of need distributed systems that we are going to incentivize with proof of stake.
When you say sample nodes, what do you mean?
Oh, for example, imagine that there's, like, some shard, which is like a kind of a subset of the consensus protocol. And you need to make sure that, like, the blocks there are valid and available. You might want to grab some nodes and tell them, go check it out. And it's easier to sample nodes in proof of stake than proof of work because the protocol has their deposits and you can sample them according to their deposits.
I think one thing that might help is a bit of an analogy. So, like, let's imagine you have, like, a fairly big and complex country, and you want to run this country with a something as close as possible to a direct democracy, right? So, you, like, people in this country happens to, like, really completely not like politicians, and they just wants to, you know, like, have the sort of direct will of the people decide everything, like, as purely as they can, right? So, one of the problems with this, I mean, not the only problem, but one of them is that, like, basically there's so many possible laws that people, like, or, like, actions that they might want to take and vote on that there's just not enough time for every person in the country to research all of them. And so if you try to just get everyone to vote for everything, then, you know, like, you would basically just get random junk because no one would even know what they're voting for. But one way that you can improve this is, imagine if for every bill you would basically randomly pick, let's say, 2,000 citizens, and it would be only those 2,000 citizens that would be able to vote, and, like, that vote would decide whether or not the bill passes. Mm-hmm. Right now, because you're randomly picking 2,000, statistically speaking, they're going to have roughly the same opinion as the entire country. At least, you know, if they can't diverge by more than a few percent, or at least it's extremely unlikely. But now, for every bill, you only need 2,000 people to spend time, like, learning about it and deciding whether or not to support it instead of that entire country. So sharding is kind of applying that same principle instead, except, you know, instead of checking bills, you're basically just validating, like, whether or not particular blocks are kind of correct and follow the rules.
And proof of stake makes it easier because you have a list of citizens, mm-hmm. as opposed to only being able to tell indirectly through the work that they produce that they exist. Mm-hmm. Mm-hmm.
Well, I want to get into sharding, and we'll get back into Casper too. So sharding is another one. As far as what I've heard for sharding, I haven't heard anything unique to Ethereum, just that you guys want to shard the database. And please educate me on sort of the details of it. But also, am I correct in assuming that it would be very difficult to do that effectively without finality? In other words, is it possible to implement just a sharding solution without actually having Casper?
Yeah, I mean, there are proof of work sharding schemes out there, but they're, less good by like a margin because you can't sample the nodes as well. It's relative. So on the proof of stake versus proof of work side, it's like relatively minor compared to the scaling advantage compared to like the distributed systems distinctions between these protocols.
Another thing that's probably worth pointing out is that there's like sharding in the sense of like sharding as in what like database engineers have already been doing for 30 years. And then there's sharding in the sense of blockchain sharding. And those two are kind of different problems. Like blockchain sharding does also involve, like some sharding of the distributed systems, like or of the traditional database type. But the main difference, right, is that when Amazon does sharding, all of the shards are computers that are run by Amazon. And so because all of the computers are run by Amazon, they're run by like possibly just the same guy who is in charge of like plugging all the computers in and installing the software, every computer can trust every other computer. Right? And so if you see a message from one computer, you can just like assume that that actually is the result of the computation. Here we're talking about a permissionless open public blockchain. And so what you're doing is kind of sharding across administrative boundaries, right? So you're basically taking work and you're splitting it up between users where the different users that you're splitting it between are like totally different individuals, totally different people, totally possibly different companies, and they don't necessarily have the interests of the system at heart, right? So like basically the sharding scheme has to be able to take that into account and be robust against the possibility of some nodes being malicious some of the time. And like that is a kind of significant challenge in the and why you can't just like take traditional sharding and just port it over.
Let's stay with this a little bit. What you're pointing out here, if I understand correctly, is if you shard the database, if you basically partition it to smaller and smaller versions of itself, it's kind of like a fractal, right? Mm-hmm. You're taking one large database and you're breaking it up into much smaller versions of the same thing.
I mean, it depends.
It depends.
It could be.
Kind of.
It could be.
Mm-hmm.
All right. Well, that's how I'm thinking about it. And so the challenge you face there is if you have X number of nodes, you're going to have a fewer number that are going to be available per shard, right? Because you don't have the security of the entire network validating every transaction. You have each shard, right? And then that shard has to reconcile with the entire network at some point.
It depends what you mean by security of. Because, like, technically it is true that, like, if you have 1 million computers in total, then 1,000 of them are processing one shard. And if those exact 1,000 happen to be taken offline or attacking the network or whatever at the same time, then yes, it is easier to attack the system, and then the entire system has to go through some fairly complex recovery process. But at the same time, like, that doesn't mean that if an attacker has 1,000 computers, that they can kind of direct those computers toward one particular shard and take it over, right? So the system doesn't let you choose which shard you get allocated to.
Right.
Kind of like how in this kind of hypothetical, like direct democratic country I suggested, like if you have, 1,000 neo-Nazis, they're not going to be able to kind of get together and say, like, we all want to be the ones that are voting on this particular bill. Like, no, it's a lottery, it's randomly selected, and chances are you're not going to have more than one of you voting on any bill at any time in the future.
When you talk about the sampling, what you're talking about is, does this also include shuffling? You're talking about how you manage to keep these shards fresh and pure so that there isn't an attempt by a malicious actor on the network to concentrate malicious intent in a particular shard.
Yeah, it's a defense against
that makes sense.
Targeted attack.
Right. So that's one component. That's one challenge. That's one thing that you guys have to figure out, obviously, if you're going to implement a sharding solution. Mm-hmm. And you feel pretty good about where you're at with that?
Yeah, like I actually think at this point we're at the stage where we're very confident that like our current suite of building blocks and our general way of arranging them like totally in principle works. And what's left is basically like implementation, optimization, testing, like narrowing down very fine details. And in some cases less fine details, but like none of the things that we're still narrowing down are kind of fundamental to the ability to shard in the first place. It's more about like what's more efficient.
So I want to also get to state channels and Plasma, but before we do that, I want to stay here. And I want to go deeper into where you're at in terms of this Casper implementation and how confident you feel about your ability to reach finality and how and humor me here to help me understand how you achieve finality, how you do that, technically speaking.
I feel like, the CBC Casper family and the Finality Gadget family both have slightly different solutions, but they're all kind of consensus protocols, and consensus protocols all somehow fundamentally make irreversible decisions out of mutually exclusive alternatives.
Mm-hmm.
And there's like a kind of consensus safety proof that shows for each of them that if there's not too many malicious nodes, then they'll be able to do this in a safe manner.
I guess like the slightly technical but still vaguely understandable explanation I could give people is that like you have this set of participants that are trying to come to consensus on things, and if 2/3 of the participants basically sign like some message that says that they agree, and then 2/3 of the participants see that where each of those 2/3 sees that 2/3 of the others has signed a message, then they can sign a message that says, yes, I see that 2/3 of people are agreeing. And once 2/3 of people do that, then like basically those 2 rounds of agreement are kind of enough to achieve a kind of lock on the message where like the algorithm has no ability to sort of move away from that message anymore.
Is there some way for someone who's interested in understanding how this works to understand it conceptually without having to go through... What if they can't understand the language of the mathematics in the white paper, right?
Mm-hmm.
Like, is there some way for someone to understand conceptually how it is that you guys reach consensus? Mm-hmm. And just to be clear, with FFG, that's in 20 minutes you have finality, right?
Mm-hmm. Yeah.
And with Casper, with your construction, Vlad, what are you looking to get?
Well, we can explore a big trade-off triangle. And so it depends on like what parameterization, but like the promise is that we can achieve theoretically optimally low network overhead or low latency or large number of validators, and but there's a trade-off between these, and so we need to kind of choose like a moderate amount of each, or
depending on the use case.
Well, depending on kind of what people want out of the consensus protocol, which might depend on the use case, but for a general purpose blockchain, it's going to be a little more subtle than that.
Right.
But, I do want to say actually that in the CBC world, we don't have this like 2/3 number, and we don't insist on the rounds thing at all. We have instead like some number, some kind of subjective number that like different nodes decide on. Just like in Bitcoin today, you decide how many confirmations to wait. In like the CBC Casper world, you decide how much fault tolerance to wait for. So if you want to wait for a block to be finalized with like a 1/3 fault tolerance, that's fine. If you want to wait for it to be finalized with less or more, that's also something you can do. And, the more fault tolerance you wait for, the more likely that you're going to have to wait longer or that it might never happen. Mm-hmm. And if you wait for less fault tolerance, then you get less of it. But kind of fundamentally, the CBC Casper consensus family of protocols is not round-based. We have like this arbitrary DAG that everything is kind of built on top of.
This arbitrary DAG, you said?
Yeah. I mean, we have like this message DAG, mm-hmm. which could look in any real shape as opposed to being round-based, right? In a round, like there's this notion that like nodes make messages kind of in sync, and that like it's not going to be that one validator makes 1,000 messages while another one makes 1.
How far along are you in your work on this?
It depends exactly what you mean. So there's a lot of work in a lot of different areas. If you're talking about like deployment for a single consensus protocol, for example, like a blockchain, it's basically the distributed systems research is almost entirely complete. And we should have like something running soon. But if you're talking about sharding, or if you're talking about the proof of stake stuff, it's a little bit earlier stage. But a sharding for me is inside the CBC Casper framework, and it's kind of related to this question you asked, but we kind of got derailed about how like different consensus protocols can decide on different types of values. And traditionally people kind of imagine that consensus protocols have to create an order of events. But that's not really fundamentally true at all. Consensus protocols are a much more broad family of protocols that can decide.
Well, you don't need to have ordering, but are you able to do ordering?
Yeah. So when I said like, oh, the blockchain thing is pretty much done, I mean like that.
So you would use a directed acyclic graph within each block?
No, all the CBC consensus protocols just like have a directed acyclic graph of messages, whether it's agreeing on a bit or an integer or a blockchain. Mm-hmm. The data structures that we're agreeing on is independent of the message structure.
Okay.
From the point of view of like the
what would that do for you in terms of ordering, like ordering transactions?
So if I want to order transactions, then I would have to either like come to consensus on an ordering of transactions. I could come to consensus on a blockchain, which includes transactions. There's a number of ways to order things.
Seems challenging.
It's not really.
I think that the core message that's important to get at is that like on the FFG side, right, like code has been written, code has been tested, and it's a matter like, and there's even a test net running for some period of time between a few nodes. And on the CBC side, and like Vlad can talk more, but like in general, like the fundamental kind of theoretical ability to establish the guarantees that we have been talking about and we want to establish is like totally there 100%. So like when we're optimizing DAG structures and message passing, like this is fairly far off in kind of optimization land. That's sort of not core, right? If you want to have something minimal, then like it actually in general like isn't really all that difficult. Like for the kind of moderately math inclined among you, I would encourage people to just read the Casper FFG paper. Like it's only about as long as Satoshi's Bitcoin white paper, and it's got pretty good diagrams and graphs.
Mm-hmm. When I say it's not too hard, I mean it's not a big difference between the different consensus protocols in the CBC family to replicate a bit or an integer or an order.
So what are the biggest challenges for you, for both of you, in trying to scale this system? What do you feel are the biggest hurdles that you're working hardest to overcome?
At this point, it's just kind of raw research and development effort, I would say. Like, I think, like, it still takes quite a bit of effort to bring an algorithm from the core set of ideas to something that has, like all of the little tiny details that make sure it works and that make sure it satisfies all different properties and make sure that you can like actually join and leave the proof of stake system and all of that. And obviously we need people to develop it. Obviously we need people to audit it, do all of the security work, and like there's still a fairly long pipeline, both in terms of like all of these research optimizations and in terms of actually building the thing.
Yeah, but I would say that like overall the research risk is actually very low, and the difficulty of the research isn't for the most part too hard. The thing that's much harder is finding qualified people who are willing to work on it and are willing to drop whatever they're doing to do it.
Mm-hmm. Yeah. So, like, well, just to reiterate, like, once again, like, there's a lot of research left, but research risk is low, right? So it's like, at this point, we're not in the stage of, like, figuring out whether or not, like, say, heavier than air flight is fundamentally possible. It's about, like, optimizing the airplane.
Mm-hmm. Just so I'm conscious about time, I want to discuss Plasma. Mm-hmm. Give me a sort of overview of what that is and what the roadmap for that is as well.
Sure. So
which Vlad is not a big fan of, I think.
Kind of. It depends what you mean exactly.
Yeah. So Plasma is basically a way to create second layer chains that sort of plug into a kind of lower level chain like Ethereum and get the what this allows you to do is it allows you to create applications that kind of derive their security from the security of more decentralized and kind of lower level base chains, but at the same time get higher performance, more throughput, lower fees, better scalability from chains that have, like either a smaller number of nodes or possibly are just entirely centralized servers, right? So like you could have a Plasma chain that's between 1,000 nodes, between 100 nodes, or you could even have a Plasma chain which is just run by one server. And even just to take the most extreme case where you have a Plasma chain that's run by one server, the benefit is basically that you can kind of send coins into this a Plasma chain contract, and this Plasma chain contract is a smart contract that lives on the Ethereum chain. And then you would be able to basically trade, like move those tokens around, do things with the tokens inside of the Plasma chain. And in this case, because it's a server, it would be just extremely fast and extremely cheap. But regardless of what the server does, even if the server shuts down, even if the server turns out to be malicious, even if the server gets hacked, if the server tries to do anything that kind of violates the rules of the system, then you will always be able to kind of appeal to the Plasma chain contract and get your coins out on the main chain.
That's a really good question, because that's what I was kind of thinking about. Let me see if I get this straight. Mm-hmm. The way I understand channels is, let's say I go to the corner bodega every day and I get a bagel. And I know that I'm going to get about this many bagels a month and I have about this much money in my account. Mm-hmm. And I reconcile that every day, or I pay for that, that I have this open channel between me and the vendor, the bagel provider, whatever. And at the end of that month, I have a certain amount that I reconcile, but then if that...
So channels are slightly different from Plasma, but I'll try to give an analogy for channels too, right? So, like, here's the analogy. Let's suppose that, like, the only way to make a payment is to, like, basically using checks and to cash checks into a bank, but the bank is not a very nice bank and it charges, say, a $5 fee for cashing checks. So here's what you do. First of all, the first time you go and buy a bagel, you write to the bagel owner a check, and you say the check, let's say a bagel costs $3, the check is for $3. The second time you go and buy a bagel, you ask the bagel owner for the first check, and you basically simultaneously rip up the first check and you give him a second check, and the second check is for $6. The next time you rip up the $6 check and you give him a check for $9. And then you keep on repeating this process, and eventually, like, whenever you end up moving out of town, the bakery owner sees that, okay, and this looks like it's finally the last check. It's got, I don't know, like $1,723, and cashes it once and pays only a single $5 fee to the bank. And everyone except for the bank is happy.
Right.
But similarly, there are some similarities between channels and Plasma, as I always like to point out. Namely, that you're doing a bunch of updates to some state off-chain, and if there's a failure mode, like if the customer just stops showing up, or if the server just goes offline forever,
right,
then you go to the chain and you can settle based on the last kind of state that you have. So that the chain as the recourse for when things go badly or when the transaction is kind of over,
right,
is like shared between Plasma and channels. And so, like, I think of Plasma as a non-unanimous channel that is regularly notarized on the main chain. But the reason why this gets kind of controversial is because people are used to channels in Bitcoin and think of channels as being always unanimous. But if you drop the requirement that everyone who's participating in the channel signs off on every state change, then it becomes very much like Plasma, especially if you also notarize with the main chain regularly so that you don't have a competition between different inconsistent versions of events.
These channels are basically like, you open up a separate accounting ledger, right? And you engage in a bunch of transactions, and then you reconcile the sort of the last transaction to the ledger when you're done, so that you save the trouble of having to do all of those on chain.
Yes.
Right? What happens if there is a dispute at the end of that? And this is what we're discussing, right? Let's say there's a dispute at the end of that, and it turns out that the guy says, actually, you never paid me anything, and this is what, I'm going to go back and say. How does that get resolved? Whereas I feel like it wouldn't be a problem if it were all happening on chain.
Okay, so imagine if, like, just to go back to the example with the checks, like, imagine if every check had 2 numbers on it. So one of these numbers is kind of like a number that refers to a kind of transaction ID, and the second number is like a sequence number. And suppose that it's illegal for the bank to cash multiple checks where the first number is the same. But for the second number, like, basically what the bank has to do is the bank has to, whenever it receives a check, it has to wait for some period of time. And if someone provides a check which is signed by the person who's paying that has a higher number, then the bank replaces that check. Right, so with the one with the higher number. Right, so basically the idea is that if, let's say, you personally have in your possession a check where the second for like some channel ID where the second number on the check, the sequence number is, say, 47, and you personally know that or let's say this check has like $400 on it going to you, right? Let's say you personally know that you never signed a check that has a number higher than 47. Then you know that if you wanted to, at any time, you could take this check with number 47, submit it to the bank, and the bank would go through its standard period of waiting for other checks. But because you never signed a check, and you personally know that you never signed a check with a number higher than 47, you know that nobody would be able to challenge you, and so you know that the bank would have to give you the $400. So, like, basically, because you know how you participated in the game, and because, like, this check has a kind of higher number than all of the other checks that you've signed, then you know that if you try to cash, you'll be able to win, and so you can, like, basically act as though you already have the money, even though what you have so far is just a check.
Okay, so high level here, where are we in terms of scaling the Ethereum network? And when do you guys think that developers will be able to build things like a decentralized Uber on your platform?
So in terms of scaling, there's multiple, I think, applications using state channels that are live on the Ethereum mainnet already. And I know there's been a lot of research over the last development over the last half year or so on making channels viable and work. So that number's going to increase fairly quickly. The Plasma side is a bit behind channels because the technology is less established, but it is rapidly getting there. Sharding, we expect to take longer because sharding is a kind of more fundamental change to the actual base Ethereum blockchain. So it's not like a layer 2 thing that anyone can just go and spin up by themselves.
Yeah, and it doesn't just benefit from layer 1 security the way that Plasma and state channels do. Plasma and state channels kind of free ride on layer 1 security for their failure modes, whereas sharding,
when we're talking about the dispute resolution, for example,
yeah. Whereas sharding, that has to be done in the protocol.
Right.
So there's a kind of
because the same protocol that the main Ethereum network is using is what the shard would be using.
That's the end goal
for consensus.
Yeah.
That's the end goal.
Yeah.
In the interim, we're likely to have...
It's a more fundamental change. We're talking about a much more fundamental change.
Yeah.
Yeah.
Or like a more kind of very different problem in terms of distributed systems.
Are there any other systems out there that you look at how they do this and you think that there's something that you can draw or you can learn from that you can implement with what you're doing with Ethereum that's useful? What are your thoughts about that? Is anyone doing anything interesting that you feel like you can borrow from, that you can learn from, that you can implement in Ethereum?
I think a lot of the 3.0 projects, and putting 3.0 in quotes, are, I think, going in a direction that Vlad and I both unfortunately feel as one that doesn't really have is kind of seriously misguided in a lot of ways. Basically because I feel like there's a lot of people that go into the blockchain space and see, oh, there is a governance problem, and the governance problem needs to be solved. Well, how do you solve the governance problem? With a mechanism. Well, the mechanism has to be decentralized. Well, what is a decentralized governance mechanism? Well, basically voting.
You're talking about on-chain governance.
Yeah, basically, exactly, right? And the problem is that even though on-chain governance often feels kind of structured and clean and decisive, it has a whole bunch of fairly serious issues in pretty much all of the implementations of it that we've seen. And even though to a lot of untrained eyes it seems like progress, I think in both of our opinions it's actually regress and potentially fairly dangerous for basically it reduces our ability to be confident that these systems will be able to maintain any particular kind of guarantees that we care about going into the long-term future.
There's no fail-safe system-wide, in other words, in a sense.
Well, the problem is more a matter of that, it's the users are not represented.
Right. The fail-safe that normally is there in blockchain governance is that people who run nodes decide whether to install upgrades. So that if the dev team is coerced to install an update, or then it will be rejected by the network. But the on-chain governance removes the necessity for node operators to participate in governance by creating a default where it just follows the on-chain governance kind of solution. And so node operators are disenfranchised from participating in governance by on-chain blockchain governance. And that basically means that the on-chain governance mechanism will be empowered and effectively will own the blockchain. Whereas today, the blockchain doesn't really have any owners. It's actually quite...
So that's a good way to transition into how governance works in Ethereum,
but
right?
But wait, there's more about why other projects suck.
Let's talk about it. Let's talk about why they suck.
So basically, to me, there's a bunch of classes. One of them is proof of work. Okay, if any project that is based on proof of work is one that I think is kind of using, a very suboptimal mechanism for doing the economics and the regulation of the protocol. So I'm a proof of stake guy. I'm really into security deposit based proof of stake. And if the proof of stake system you're proposing doesn't have security deposits, then I'm sure that the robustness
things that you could lose, in other words, if you act badly.
Yeah, and then definitely the equilibrium of the protocol, if there even is one, isn't going to be as robust as it could be if you use security deposits.
Can I ask you something about that, though? Because that's a game theory approach, right? What you're saying is that you got to have money at stake, because if you don't have money at stake, you have nothing to lose. But what if you're your nodes are infected and they're acting in a way that's not sort of in the best interest of the node, were the node to be assumed to be a sort of self-interested homo economicus.
Yeah, well, I mean, I also believe in kind of forgiveness, which is to say that, like, if a node exhibits a fault, but it doesn't cause a failure, it's not an attack in the sense that it's not a successful attack.
This is like a New Testament POS.
Yeah, exactly. I used to be very Old Testament, where I just like burn down the whole city if there's a single sinner. But now, you know, if there's just a few sins and they didn't cause any damage, then they don't need to be penalized quite as harshly.
This seems exponentially complicated because of the game theory aspects of it, because of the fact that you're dealing with human beings and attack vectors that are sort of off the charts.
I would not say that it's exponentially more complicated than proof of work, like maybe 2 times more complicated. And as I said, right, like the Casper FFG paper is basically about as long as Satoshi's white paper.
And also, thankfully, we get to think of the robustness of our equilibriums independently of the incentives that happen outside. We can kind of maximize our security against the outside world by just pulling as hard as we can towards the protocol guarantees being satisfied. But that's just on the economic side. And then I also have lots of things I don't like when people do on the distributed system side, right? Like, I'm a huge fan of sharding. If the scaling solution proposed for a project isn't sharding, then I'm not too happy with it. And I have like other relatively minor pet peeves. Like, I don't like in-protocol fault tolerance thresholds. I think that's relatively
What do you
minor.
mean when you say that?
Like the classic thing is the 1/3. Everyone's always talking about their 1/3 fault tolerance, and that's how that's theoretically optimal. And,
right. Well, that's Hedera Hashgraph, for example, says it.
They're not alone.
Right.
Right.
And why don't you like that? What's your reasoning for that?
Because I think that it's completely possible to have consensus protocols with extra protocol fault tolerance thresholds, which means that, like, the protocol doesn't need to decide, the protocol developer doesn't need to decide, but the user can decide, you know, I want to tolerate 1/3 equivocation faults and 1/3 liveness faults. Or they can decide, I want to tolerate 50% equivocation faults and 25% liveness faults, as opposed to kind of blank boxing these things as Byzantine faults and not saying what kind of faults they are. So I think that basically, because people think of Byzantine faults as in this kind of general abstract way, as opposed to thinking more concretely about what exactly are the crimes that we're talking about, the fault tolerance profile that people imagine is basically that 1/3 is the maximum. When really, when they're choosing a third, what they're saying is, I want to tolerate 1/3 for safety and 1/3 for liveness, because that kind of maximizes my fault tolerance in the worst case for either. Whereas, like, you know, I personally would be much happier tolerating 50% for safety and 25% for liveness. But I don't want to make this decision as a protocol developer. I want, like, the nodes to decide, just the way Bitcoin nodes decide how many confirmations to wait.
How would they decide that?
So there's a couple of ways. One of them is, like, you just watch how much fault tolerance blocks end up getting, and then you know, once you feel comfortable, you go with it. And the other is you could literally, like, you know, code it into your apps or like plug it into the command line or into the user interface. So, like, for example, imagine if you're programming an exchange.
The application developers would be able to decide what fault tolerance.
Like the exchange decide how many confirmations to wait before they accept a deposit. They could decide how much fault tolerance to wait.
So what happens if you have a lot of developers that don't know what they're doing and they develop, let's say, you know, they give too much leeway and they end up, let's say, building multi-billion-dollar software on Ethereum, and then they miscalculated, for example.
Sure.
That's a very interesting thing to say on the DAO fork anniversary.
Is today the DAO fork anniversary?
Yeah, 2 years.
Oh, that's amazing. Well, that's another good point of the importance of governance, what you guys did on the DAO fork, right? I mean, you had the ability to make a decision about what you wanted to do or not. That was like the crisis control room. What was that like? That was that on the bunker. That was like the day that the U.S. government took out Osama bin Laden.
Well,
we weren't in a room.
We weren't in a bunker.
I was in Shanghai. A bunch of developers were in Europe. What continent were you in, Vlad?
I was in Canada.
Okay, yeah, see, we cover 3 continents.
But you were virtually in the same bunker.
Well, but
you were in the same shard.
We're in many different channels with many different people talking about this, right? You had to. So the threshold of attention that the Ethereum community paid during that time was very high.
But to bring it back, because it is a serious question, right? Which is that you're basically, in what you're describing here, you're forfeiting control, a great amount of control and agency over to the developers. Is that not a concern? For the same reason.
To some extent, but, you know, I mean, people today, you know, do decide whether to choose 1 confirmation or 6 confirmations or 0, and it's not a disaster. Even though, like, to me, like, both 0, 1, 2, 3, and that's all kind of.
But that's only
sketchy.
for
zero conf is sometimes a disaster.
Yeah. Yes, I was about to say.
Yeah.
We're talking about the probabilistic consensus.
No,
for
I'm talking about
Bitcoin
in
primarily.
Bitcoin. Yeah, exactly.
Yeah, like how long do I wait? Depends on how valuable the good is that I'm transferring.
Yeah. And so, people have heuristics that they develop and share for these things.
Interesting.
And it'll be the same. It's a matter. Just like with the DAO hack. The reason why the DAO hack happened was because there was a developer norm that not to have these reentrancy bugs. That didn't exist at the time, although today it really, really, really does, where everyone kind of knows not to write that exact bug.
Yeah. If all else fails, just play the safe academic route and choose 2/3.
Not me, no.
There's a lot of disagreement here. So
wait a second. So no, I misunderstood. I thought he meant as the protocol developer.
No,
as
a
user,
client developer.
So
let me ask you one last thing, guys, because I did want to get into governance, but we have a limited amount of time. So this is a good example, which is that there isn't clear governance in the blockchain community. It is open source software, right? So you've got developers, you've got miners, there are different stakeholders. You have Vitalik, are you Vitalik something more like Queen Elizabeth today? Are you more like Victoria? What is sort of your role in all of this? I've heard, some people say, Vitalik the benevolent dictator. What do you think is the most accurate view? Are you a sort of a vote breaker in the middle, like your tiebreaker?
I guess one thing that's very important to point out is that obviously my power isn't zero, because there's a whole bunch of people that listen to me and all those Twitter followers and so forth, but both of our power is almost entirely soft power, right? So it's almost entirely based on basically the respect that the community has for us as a result of our track record of being able to produce good research and come up with good protocol ideas. And if, let's say, for example, one of us got captured by some crazy third world government, and then that started trying to extort us to put backdoors into the protocol, sure, I'll write the EIP, I'll write the code, the number of people who would listen to that, and probably pretty close to zero.
Well, that's true. So the open source nature of this protocol prevents really bad things from happening in that sense. But it also makes it very difficult to move forward, right? Because you can get stuck in the mud, right? For example, if you guys want to move forward with Casper, let's say, in a fully POS solution where you get rid of proof of work entirely, isn't that going to be a problem for the miners?
Yeah.
And are they going to create problems in the implementation of that?
So basically there's a political process by which kind of the community makes up its mind about what to do. And then what to do in political gridlock is kind of one of these questions, right? In the Bitcoin world, they have this norm against contentious hard forks. In Ethereum, I don't think we really have that. And I think that's ultimately the way that even if we can't agree, something will happen. And I think the DAO hard fork was a good example of a contentious hard fork. And I personally have no qualms with doing a contentious hard fork if the miners don't like proof of stake.
Another practical thing to point out is that I feel like basically almost the entire Ethereum community supports proof of stake, and especially after the DAO fork, basically that ETC ended up absorbing a lot of the proof of work fans, and chances are they are going to either stick with a proof of work or go with some Ouroboros hybrid thing that I'm not exactly sure of about the details of. So
I guess here, let me ask you this last question: are you hopeful about the ability to overcome the challenges that you guys are facing to scale? We've talked about some of them here today, and if so, what do you think the timeline looks like when, again, to bring it back to the point about development on Ethereum, where a lot of these projects that have gotten funding, for example, or that are trying to get funding to build distributed applications on top of Ethereum, that they'll actually be able to do it, that you'll have the throughput, that you'll have the low levels of latency.
Yeah, so I think, first of all, if you're impatient and you want scalability, then, choose channels and Plasma, right? Because, channels are basically, and there are versions for specific use cases that are pretty much ready for use today, and Plasma implementations are making very rapid progress, and we can expect them to be, I think, to be done within this year for in at least some cases. The kind of full dream of, base layer, sharded proof of stake, especially with all of the different properties that we want, will probably kind of come online in stages over the next few years, and that's more difficult to predict.
For the most part, I feel very optimistic about tech governance. I'm much more pessimistic and concerned about governance with respect to irregular state transitions and things like reversing harms, preventing harms, and dealing with malicious applications. Those are kind of much more contentious and difficult governance questions than will we be able to upgrade the tech.
Guys, I appreciate you coming in such short notice. I wish we had more time, and I wish you the best in your travels to, where are you going next?
Ithaca.
Do you have a home, or are you just like perpetually living out of a suitcase?
Perpetually living out of a 40-liter backpack. But
do you have to pay taxes? Because, I mean, you Doug Casey, we talked about Doug at the start of the show. To close it off, Doug doesn't have to pay taxes. He's an international man of mystery. He's not domiciled anywhere.
And I think cryptocurrency people tends to care particularly about capital gains, and there's actually a number of fairly mainstream jurisdictions that don't even have taxes on capital gains, so it's a bit easier.
Is that where you have your Lambo, Vitalik? I'm just messing around, man. All right, guys, thanks for coming on.
Yeah, cheers.
Cheers.
And that was my episode with Vitalik Buterin and Vlad Zamfir. I want to thank both of them for being on my program. If you're a regular listener to the show, take a moment to review us on iTunes. Each review helps more people find the show and join our amazing community. Today's episode was produced by me and edited by Stylianos Nicolaou. For more episodes, you can check out our website at hiddenforces.io. Join the conversation at Facebook, Twitter, and Instagram at hiddenforcespod, or send me an email at dk@hiddenforces.io. As always, thanks for listening. We'll see you next week.